So good afternoon, everyone. Good afternoon, everybody. Did we go through what we sent to read up? Did anyone go through it? No. Yes, networking. We sent some topics to be read. Did anyone go through it? Course rep. She's not here. Okay, did anyone go through it? Let's indicate. Anyone here? No, indicate. Let's know. Those that went through it. Nobody. We may do an assessment if no one went through it. If you went through it, indicate. Okay. So I think three of you and you come and help us. Just in 1 minute, tell us what you got in networking. Come out, please, come out. Yeah. The mic, you give him the mic. Make it snappy. No much time. Make it snappy. Just 1 minute. Your name and tell us what you got from there. Just 1 minute. Not group, you as a person. Just your name, then tell us what you got from there.
My name is David.
What's your class? David, your surname?
David Ubanto.
Okay.
So, from networking concepts, we got that systems are able to communicate with each other.
You read it with people. Okay.
Systems are able to communicate with each other through wireless networks and wired networks where they can pass information between each other, whether media documents, files, and those sort of stuff. They are secure ways, and there are some that are not so. Yeah. Then, in the application of wireless networks, we have local area networks, wide area networks, and macro area networks. Then we have man area networks. Those are for personal use for select individuals. Then for local well area networks, those cover like more like, let's say, campus or something.
So the next person. Your name, please, and your surname. Isaiah. Okay.
Okay, the research I did about the networks, I found that networks are devices that are used to connect to transmit data or resources. And then type of networks like switches and routers and networks that are used in networking. And then we have types of networks like LAN, we have WAN, wide area network, super area network, we have metropolitan area network, and other types of networks that we have. And then we also have types of cables too, or I've forgotten the word, what type of cables, like twisted pair cables, we have shielded and unshielded pair cables, and other types of cables that we use for networking.
Okay, the next person.
Networking is about connecting devices from one source to another. We have WAN, LAN, and LAN. Local area network, wide area network, and metropolitan network. Sorry. So in the local area network, I just collect device for about 55 people. It's not actually something that you can move to wide areas, so it's just within a specific space. Therefore, wide area network, you can go as far as 100 meters. You can connect about 100 devices to the source. Therefore, metropolitan area network is for a large geographical zone, countries and cities. You can connect a lot of devices, so on and so forth. We have about networking like wire, we have twisted cables, and we have fiber optic cables. For twisted, we have shielded and unshielded, and the fiber optic cables we have solid fiber and so on and so forth.
Okay, thank you very much. So we'll spend just 1 hour on this. Then we may stay till 5 doing the practicals. 5 p.m. 5 p.m. Any issue with that? Let's go on. Let's go on. So under this module, we'll be looking at networking concepts, networking types. We'll see how the internet works. Then we'll look at LAN cabling and standard color codes and types of cables and how we can construct them. That will be the lab. So we'll rush through this because we are meant to read it. I also dropped the slide. I have dropped the slide with the course rep. So she's going to... No, I sent it today. Previous one you would ask her. I may not know, but she has everything. She has the slides I've given to her. So a network, let's be together please. A network can be defined as a set of computer systems sharing resources together. So network is simply comprised of different systems connected by a particular device. For instance, those that like sharing hotspots. Once you put on your hotspot, for one or more persons to connect to your phone, you have created a network. Is it clear? Once you put on your hotspot, you have already created a network. The only difference is that you have created a mini network within your own environment. So when we are talking of network, so far you are sharing information between one device and another. That is a network. That is a summary of this entire slide. So it is that same network that allows us to go to a cyber cafe, sit on a system and print. And from your system, you receive the document on the printer. It means that that printer is on the same network with the computer system you used. And it's that same network that allows us to send email addresses between one or two people. Let me just explain that concept, and I'll use that to explain some other things. I told us in the previous class that when we are talking about, I don't know if it's this class, when I say we are talking about data centers, that's simply computers located somewhere. Did I make mention of that in this class? No. Okay, so let's explain. But you have heard of cloud. Cloud. Who can tell us what cloud means? When you hear cloud, they tell you cloud. What do you think is cloud? One person, please, not random. Cloud. This group 2, cloud. Cloud. What do you understand by online storage? So what is online? Sorry? Okay, so that means online is the sky or something. Maybe the moon somewhere. A server located in where? Okay, let me explain what cloud is. It's very, very simple. So whenever you hear the word cloud, though it is a big term used to deceive people, but it's very simple. Let's give this assumption. My laptop is here, and I have all your results on this system. Possibly, I am connected to the internet, right? My laptop don't have any name called www. whatever. Someone in UK wants to access his Uniport results, and they tell him the result is already online and it's on the cloud. When they say online, they're simply saying it is located on somebody's system where you can access with the use of internet. Now, when you say internet, let me explain what internet is. I'll use some cables here. Okay, I will explain these things later, but I just want to make a short demonstration. What else? Yeah. Who have heard of the word fiber optics cable? Fiber cable. Okay, some of us. Who see those that dig along the road? Those people that are always digging. And they are putting brown or orange or green pipe. You see them. What do you think they are digging? They are laying. Sorry? What type of cable? Network cable. They are installing fiber optics cable. Fiber optics cable can travel for as long as 100 kilometers. So let me tell you what happened when you are browsing the internet. This cable now, like one of the sites I'll take you to, you'll see it. This cable can run underground from ICTC down to Transamadi. Another one runs from Transamadi straight to Lagos. Then another cable runs, this same cable runs from Lagos straight to London. From London, it goes to maybe South Africa, UK, whatever. So, Google now, maybe those using Gmail. Gmail is actually a computer somewhere, sitting somewhere. That is Google. It may not be one system, it may be a stack of computer systems sitting somewhere, maybe underwater or in a room. So whenever you open your system and type www.gmail.com, your system now searches for the internet you are using. Let's say you are using MTN hotspot, right? That means your system transmits that information to your phone. Are we following? Are we following, please? Your phone transmits that information to the nearest MTN mast. Hope you know what is mast. That MTN mast now sends that information through a cable in that mast running underground straight to London. London sends it to Google, a computer like this sitting somewhere, sends it to that system. That system has all your emails you can think of sitting down there, but it is always on 247. So whenever you are typing gmail.com, you are simply accessing another computer somewhere very far. That is the summary of internet. No to worry about it. So what now makes it complex is the flow of information. Let's say Uniport, your results may be in ICTC on a computer somewhere that don't go down. ICTC may be using Airtel network, not MTN. So you are using MTN. For you to access your results in ICTC, it has passed through to MTN server in South Africa. MTN get their internet from South Africa. So it goes to South Africa. Airtel gets their own from another country, maybe from Dubai. So it goes to South Africa, then goes to a place in Lagos called Internet Exchange Point of Nigeria. When it gets to Lagos, ICTC that uses Airtel has also gone to Lagos. At that point, those two internet connections jams together and an exchange occurs. And all this happens in milliseconds. That is why once you want to check your mail or once you send a WhatsApp message, there's a place on your WhatsApp that will tell you where your server is located. Some of you may not see it. If you open your WhatsApp, go to settings. It will tell you data center in Ireland or somewhere. It is telling you that whatever chat you are sending, even if you receive it right now, it has traveled around the world before you get a response. If you send a message to her, that message has gone around the entire world and comes back to our system. In one of the practicals we are going to do sometime later, we are going to simulate a system being a server, and we are going to simulate other systems being connected to that server. You can practicalize what I'm saying. Any question on this? So we now go into types of network. We have various types. Number one is called wired network. Wired network is simply a connection of two or more systems with the help of a cable like this. If you look at your back, you are going to see, please turn to the back. You see all those things there. That was why we asked to use this class. All those things are wired cables that is connected to what is in front of you. If you look at your table, you are going to see some socket in front of you. Those are not, if you check, you can plug your phone on some of them. So all those cables come to this socket, and those sockets can connect to somewhere on your laptop, which I'll show you. So wired connection is simply a connection of two or more computers linked together by a cable like this. And those cables are linked together to a central device known as a switch, like what is up there. I'll show you a sample. You may pass it round. Please, you make it very snappy. Just take a look and pass it around. So this is a switch. So a switch connects two or more computer systems, and that is what we call wired networks. And these are samples of cables. Those that are red, all these cables are actually what is here. These are the cables that connect wired networks together. I've showed you fiber optics already. Unshielded or shielded, this is it here. So with this, you plug on your system, plug to the next system, plug to the next system, to the next system, till you get what we call a wired network. We will do this much later. So this is a simulation of what I just explained. So as you are going to see, when please, let's pass it very, very fast. As you will see, that device is what is here on the screen. So assuming we are going to create this cable. After creating it, we are going to connect it to, we can connect about 1, 2, 3, 4, up to 24 systems to that same device. So in a CyberCav, what actually happens is that a printer is connected to that same device. That is why you can stay anywhere and print in this class or in this building. You can print from a system and it comes directly to the printer because we are using a wired connection. We also have what is called wireless network. A wireless network uses radio wave to communicate between each other. What do we mean by wireless network? I'll show you another device. A sample of a wireless network is your hotspot, but this is one equipment. I think we'll start from here. You can pass it around. No, we'll start from here. So what this does now, you go to some buildings and you see this on the wall. Am I right? This is what is called a Wi-Fi access point. So it also has a slot for a cable. So with this Wi-Fi access point, once it is on and you put on your phone, you simply see the Wi-Fi name which you connect to. So an access point is used to create a wireless network. You look at it and pass it around. An access point is used to create a wireless network, just like what you see on the screen. You can see the access point at the center there. Let me get it. Okay. So this is an access point at the center here, and these are the systems with Wi-Fi that are connected. This is the actual access point which we are passing around, and these are samples of systems connected. So if you are asked what device could be used to create a wireless access point, it is simply what device could be used to create a wireless network. The answer is a wireless access point. What device can be used to create a wired network? It is simply a switch. Now let's now see advantages and disadvantages of the wireless network. Wireless network may allow for wireless remote connection. You know, with wireless network, we don't need to run all these cables. So I can simply put on my hotspot or bring in a Wi-Fi device and everybody can connect to my network. And with wireless network, we can easily expand our network without too many disruptions. Imagine we trying to create a network in the other class. Remember the other class that didn't have this? If you want to create a network instantly, you can start doing this. But with Wi-Fi, you can simply set up that device and everybody connect instantly. Disadvantages, we will look at this very well in our defense class. Wireless network usually have a lot of cyber security issues. And wireless network is not fast compared to wired network. What do we use to access wireless network? There are some things we call Wi-Fi adapters. The modern systems of today have inbuilt Wi-Fi. But some systems that don't have inbuilt Wi-Fi, sometimes you go and buy some things like this, very tiny. You just go to any computer shop and tell them your Wi-Fi is not working, and they will give you a wireless adapter. But nowadays, all systems or most systems come with embedded Wi-Fi on your system. Let's look at some critical terms. Please, this slide is very, very important. When you get it, you study this particular slide. We have what is called wireless repeater. What does repeater do? Repeaters are used to extend the range of an existing signal. Let's give a typical scenario. So that device you are passing around, possibly the Wi-Fi strength just extends to this class alone. So let's say we have created, please you pass this one round. This is also a Wi-Fi access point, but it's a different shape. You pass it round there, then they are already seen the wireless access point. So assuming, let's give an example. What if I'm in the other class and I want to connect to the Wi-Fi in this class? What do? I simply need to purchase another wireless access point like this and mount it in that class. When I log in, I will see something like a repeater mode. We call it repeater mode. Repeater means rebroadcast. Rebroadcast means search for a Wi-Fi. When you search for that Wi-Fi, connect to it and extend it to another location. So that is what we call repeater. So wireless repeaters are used to extend the range of an existing network. We also have what is called a router. A wireless router can convert an internet connection to a new network to share it among users. An example of this is your mobile phone. Your mobile phone converts your MTN or Airtel network to another. Remember, when you create hotspots, you give it your name, am I right? And you can even tell people to pay you to use your own network. What have you done? You have converted MTN or Glo's internet network to your own personal network. So your phone is actually called a router. Whenever you create an hotspot with your phone name has changed to being called a router device. Are we following? We have another network type called an hybrid network. What is an hybrid network? Hybrid network simply allows you to combine both wireless and wired network on the same network, still using the access points. If you look at the access point passing both the white one and the other white one, you will notice that there's this hole under where you can plug a cable. So assuming this class has a wired network already existing, you can simply plug a cable to that device and plug the other end to the other device at the back. And immediately you have linked this wired network with the wireless network, making it an hybrid network. We will still practicalize all of that. But for now, you should just know that an hybrid network is a combination of a Wi-Fi and wireless using an access point connected to a switch. So once you do that, maybe that switch you are passing around can only take 24 systems, and you are 100 in this class. So once you plug in that access point here to that switch, you can connect maybe an additional 50 people to the computer system. We come to another concept called network topology. Network topology simply has to do with the design. As a network engineer, you have to be very, very concerned with how you design your network. Let's give a typical case study. If you notice this equipment on your table, you can look under. You may not see how the cable ran, but if you look carefully, please, let's look at our table. You will notice that there's a black pipe under there. That black pipe is actually the design of this network. So the people that designed this class ran a cable using that black pipe, connecting each of these tables to that device at the back. So the next question is, what kind of topology did they use to create the network? We have about 5 common topologies for network. We have the bus topology, we have the ring, we have the star, we have the mesh, and we have the wireless. We can ask you to write on network topologies. When we say write extensively on network topologies, we are simply saying write on the bus, the ring, the star, the mesh, and the wireless. And we can also ask you to differentiate between different types of topologies or network. Now let's see the difference. With the bus topology, you can notice that a cable is just passing around. This is the cable. This green is the cable. As the cable is passing around, systems are simply tapping to. So systems are simply tapping to that particular cable using some kind of connectors. This was practiced many, many years ago. But there are several disadvantages. The disadvantage of this, let's see it. The bus topology is very, very easy to implement, because with the bus topology, I can simply run this cable in a cyclic format and everybody simply tap, just like you do in your hostels. When you are tapping lights, you just scrape the electrical cable, plug the other one, and use sellotape and cover it. That is very, very easy to implement. That means with one cable, I can have everybody in this line simply tapping to this cable without necessarily connecting to the device at the back. So the bus topology is very easy to implement, requires less cable, and does not need any specialized equipment. What are the disadvantages? Once any part of the cable is disrupted, the entire network goes down. Am I correct? Those that do those connections in the hostels, if you are looping from hostel A, Mandela block A to block D, just one electrical cable goes there. Those using iron hot plates connect there. Electric iron, that same cable. Microwave, that same cable. Once in block B, someone uses air conditioner on that cable and it melts. It means that block A and block C has been disconnected instantly. That is the disadvantage of a bus technology. Network disruption occurs when computers are added and removed. This is what in electricity we call voltage drop. A cable that is meant to power electric bulb, the guys in the hostel tap from there to power your iron. Once they plug iron, you suddenly notice that the color of that bulb has changed from bright yellow to a very dim yellow. That is network or voltage drop. Let's see the ring topology. Using the ring topology, it means that data travels in. Please, no noise. With the ring topology, it means that data travels in a circular fashion from one computer to another, just like this. From one computer, it goes to the next one. From the next one, it goes to the next system. From the next system, it goes to the next system. Advantages: cable faults are easily to locate. Because how is it easy to locate? If my computer is faulty, I simply need to ask the next person, are you receiving network? Once it says yes, I know that maybe it is just my own cable that is at fault. But what are the disadvantages? Expansion to the network can cause network disruption, and also a single break. Look at this diagram. This is a ring topology. I connect this to different system. If this system shuts down, it means that, and assuming this is where the modem is connected to, the modem is connected there, this is where the internet is. If the system shuts down, it means that system number 1, 2, 3 immediately goes down. So that is another a disadvantage of the ring topology. Now, the star topology was introduced. Using the star topology, all computers are connected to a central device called a hub or a switch, which is this. This is what is commonly used these days, which is a star topology. It means that every device needs its own cable to connect to the network. Every device must plug a cable directly to the network. And that means once there is any failure, it must be these equipments that has the failure. Once this equipment goes down, all the network goes down. Or possibly once a system goes down, the light here turns off. And you can then know that a particular system has the issue. The advantages: you can easily expand any network without disruption. Why do I say so? Now, this is a 24-port switch. Let me show you a bigger one. Sorry, this is 16. Okay, sorry, 16. So this is a 48-port switch. 48 ports. So what happens is that, let's assume the internet comes from 16. The internet comes from 16. And the class is more than 16. Using the star topology, I just need to carry a cable from here, this side. Maybe instead of connecting the number 23rd person, I'll put a cable there and put on possibly number 1. Once I put on number 1, I have linked both of them together. It means that an additional 47 people can connect to the same network using this star topology. I won't pass this round, please. It's a brand new equipment, but we may use it for practical. So, let's see the mesh topology. Using the mesh topology, every computer system connects to one another. Please, let's pay attention to this. This is a very possible examination question. Using the mesh topology, every computer system connects to one another. And there is a very high level of redundancy. Who can explain what redundancy means in network? When we say redundancy, high level of redundancy, what do we mean? Anybody can attempt it. Redundancy. Anybody? Redundancy. Anybody to attempt it? When we say high level of redundancy, we are saying there is almost no downtime. There is almost no downtime. Let's talk about Google again. Using Google, we are saying that Google is not meant to go down, or Facebook or WhatsApp. WhatsApp is never meant to go down. Meaning that if WhatsApp is saving all your information on this computer system, the information for Australia is on another computer system. Information for Senegal, another computer system. And all of them are linked together. One system must not go down. So what they are now doing, They are now saying that the entire African's WhatsApp can be on this laptop. But what if this laptop goes down? What happens? They bring another laptop. They may have about 5 different laptops with just the data of this classroom. So whenever you upload a file to your email, it enters those 5 laptops. And those 5 laptops are connected. That means those laptops won't just have one port to put this cable. They have several ports to put the cable. And all those 5 are connected to each other system. So that for whatever reason, if this one goes down, the other one immediately takes over. Are we getting it? If one goes down, the other one takes over. So when all of them go down at the same time, that is when you usually notice that people, you go to Google, WhatsApp is down, Facebook is down. You send a message, it can't deliver. Have you experienced that before now? That is also actually happened. It means that an entire data center with many systems have gone down. It can happen through power cut or whatever could happen. Or it can also happen as a result of an update. We learned updates in the other class. Someone was making an update and the update didn't complete. As it didn't complete, all the system went down automatically. Let's now see network types by area. Someone explained to us that we have several network types when we are talking about LAN, WAN, and all of that. We have personal area network, we have local area network, we have metropolitan area network, we have wide area network, private, and we have wide area network public. I will explain all of that. Personal area network simply means hotspot connectivity, a network that we create for our own self. Let's say in this class, we need a network for cyber security 200 level. I can simply ask you with lip gloss. So what's your name? What's your name? You are doing lip gloss in class. What's your name? Sorry? What's your name? Praise. I can simply ask Praise to create a hotspot and name it Cyber Security Year 2. Once she does that, it means that we have created a personal network in this particular class. Is that understood? Is that understood, please? Local area network. Local area network can connect groups of, please, this word looks quite big. It just means groups of devices or systems across short distances. For example, across particular buildings. Let's say we are in this class. There is another class that has all of this still within this building. Somewhere, I can't remember, somewhere around. So, this switch you are seeing here, a cable is running from this switch to another class. From that class to another class. That means we have created a local area networks amongst this particular building. It is local because it's among this building. That is why we call it a local area network. University of Port Harcourt, let's assume this cable is connected to that class and they have another office. There's an office, those of you that go to pick up things for this class, that office has this type of box. And that box connects all classes to that office. From that office, a fiber cable runs from there to ICTC. From ICTC, another cable runs to all other departmental buildings in Uniport. That means we have a local area network within the university facility. When we start our site visit by last week of January, we should be able to appreciate some of these things. So the device that connects networks to each other is called a router. We have already talked about a phone, but let me show you another router. So we'll pass it around. This is a router. As small as this device is, as small as this device, it looks like a switch actually. Because I'll pass it around. It has ports like a switch. So a router and a switch has ports, but by function, this does a lot of things. This is similar to this. Hope you know what this is. Sorry? Who knows what this is called? Who knows what this is called? Sorry? So our houses and hostels, you see this, but you don't know the name. Circuit board, distribution box. The function of this thing is to regulate all the entire lighting, fan, electrical points in this particular classroom or maybe building. That is what a router does. As small as this thing is, this small device can control the entire University of Port Harcourt. As small as it is. We will practicalize with this. We can tell this device any cable, this cable connected on, this is called port. Please, in networking, we call all these things port. P-O-R-T, port. P-O-R-T, port. So I can tell this device, any cable connected on port 1 should only be able to visit Facebook, or maybe should only be able to visit Google, but they shouldn't visit Facebook. I can tell on port 2, any device connected on port 2 should never download movies. Any device connected on port 3, they should be able to watch YouTube. Any device connected on port 4, they should only be able to check their results. Any device connected on port 5 should ask for username and password before login. This small device does all of that. This small device can also tell me exactly what you are browsing so far you're on my network. Yes, this device can do it. Sorry? Even in? Yes. We will practicalize it in this class. Whatever you are browsing gets translated to numbers. I will show it to you. Whatever you are browsing, any website you are browsing gets translated to numbers. So no matter what you, that is why whenever they say security, maybe email things secure, sometimes it's just relative. Because if you think you are browsing on a private website, fine and good, the owner of the laptop may not know where you visited. But a cyber security, even the network guys in ICTC may not know what you visited. But a cybersecurity guy can simply open up this device. Whatever you are visiting comes as numbers, maybe 11111, 22222. I can carry those numbers and put in somewhere, and it will tell me that you are visiting Google, or you are visiting a website you are not meant to visit. And that is why, if you are on my network, that is how EFCC gets some people. Or if you watch those horror movies, you just see them coming to a particular house and arresting just one person. Or sometimes you wonder, how do EFCC knows that this compound is a compound that houses the Yahoo boys? They'll just come and pick their laptop. It's because MTN, Globalcom, whoever network are using, have this device. And once they send that information to the due individuals, they analyze it and they can tell exactly who perpetrated whatever crime. So the world is actually not safe. That's the bottom line. The world is not safe because whatever you think you are hiding can be discovered. You can pass it around. So a router connects different networks together. Please, one else. So metropolitan area network. Metropolitan area networks are networks that covers areas larger than a local area network. For example, this is Uniport, this is UST, and this is Uwofe. If you are sending a message from Uniport to your friend at Uwofe, that means a service provider must link up both of them. Or let's give another case study. Let's say Uniport has a branch at GRA. They have an open university at GRA. And Uniport also has a branch. Let's say Abuja Park, Choba Park, and Delta Park. How can we interconnect them? We can still create a metropolitan network with those 3 campuses, but we must make use of a service provider. And Uniport may have a branch in Lagos. A service provider are those that provide internet service like MTN, Airtel, and Glo. So I can tell MTN and Airtel, I want to be able to send a private message from my system. Maybe, who is a software developer here? 2 people. How many, please? Can you develop a communication app? Maybe just a tiny chat application. You can. Or let's say a file transfer app. Okay. So let's say he has developed a file transfer app that is meant for cyber security class 200 level. Cyber security class, due to COVID, we now have satellite centers, maybe Lagos, Abuja, and all of that. We now connect, we designate some buildings in those places as study centers, so that when you go there, you are meant to be connected to only, you are meant to access our server, just you alone. So if we develop that app and we host it on this computer system, when you go to those places, you are meant to send your file from here and receive it over there. We will now meet MTN and go and tell them, please, I want you to create a private network within your public, you know, MTN is public. You ask them, please create a private network within your public network such that only the files meant for Uniport are seen by Uniport people anywhere in the world. That is when we would have a metropolitan area network, because you are now using a service provider which is usually denoted as cloud. A service provider to connect all our buildings together. That is a metropolitan area network. A wide area network covers a large geographical area. The difference just between these two is that metropolitan can still be owned by a particular community or organization, while wide area network means it is open to everybody. And we also need the service of a service provider to connect every one of us. Let's please examine this. This is very, very easy to understand if you look at it critically. This is what we generally call an internet cloud. But let's break it down. This is cyber security class A connected to Praise Hotspot, right? On the internet. This is cyber security class B connected to another person's hotspot. Both of them are visiting the internet through another router, maybe MTN mast, whatever. This someone's another person, this is Google possibly with their email address and whatever. This is someone's home, connecting to your home internet, maybe hotspot or Wi-Fi box. You are browsing. This is another person's house. This is Google and that is Facebook. Everybody comes together to what we generally call the internet cloud. And this cloud, as I have told you, it is not any imaginary cloud. It is just a combination of several internet devices and several cables running thousands and thousands of kilometers to link up themselves to form what we call an internet cloud. So the internet is simply a global system of interconnected computer networks that connect all individual networks to each other. So as students of this class, nobody should now come and tell you cloud, 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 and you are deceived. There's nothing like cloud in quotes. Cloud is simply computers connected together somewhere that is hosting information. So any system can be a cloud. I can be a cloud. As part of the visit, I'll show you. I'll take you somewhere where they have a server sitting down somewhere, also hosting some of the websites you guys type. And we may call it cloud subscription. Cloud subscription. People are paying just to access that computer server. So those networks could be government or whoever. Now, This point is very important. Every device on the internet is uniquely identified using what we call an IP address. Let me repeat. Every device on the internet can be uniquely identified using what is called an IP address. Let me show you how to identify the IP address of your device. Can someone create hotspots? Can someone create hotspot for us? Anybody? Okay. Please, can you create without using your data? Okay, create an hotspot for us. Just make it open. Please, have you created it? Okay. Okay, so I can connect to your hotspot. And what's the name? Sorry? Technospark 10C. Can someone else connect to his hotspot? Okay, I've connected. Okay. So let me show you something. On my phone here, you can go to your Wi-Fi's to see the Wi-Fi you are connected to. So on Technospark, I'll click on the setting. I've clicked on the setting on my phone, and on my own phone, I don't know how yours look like. I've clicked on View More. As I scroll, it is showing me a place for IP address. You can create hotspots among yourself and connect among yourselves to find it. It has shown me an IP address. I feel another person, please, can someone else connect to his hotspot? Emanuela? Yeah, Elabi? Please connect and show us if you have seen the IP. Someone else should connect and confirm it. Have you seen the IP address? Okay. So that is to tell us that every system is uniquely identified with the aid of an IP address. And it is that IP address that we use to detect those connected to our network and those performing any kind of activity. Now, because this is a phone, he cannot use his phone. If he owns his phone, he will only see that 2 or 3 people are connected. But using that device we are passing around, if I create a network with that device and you connect to it, it will tell me the IP address, it will tell me the name of your phone, it will tell me the manufacturer of your phone, it will give some other details of that particular. It will even tell me the name that you have used to rename that your phone. So just you connecting to that device, I can get a lot of information about you. And what I just need to do is to mark the IP address. Now, I'm seeing that if he checks his phone, he may see that he has assigned me an IP address of 192. something. So if I mark that IP, I start maybe I'm suspecting one of you for something. I can then, you have seen it. So I can then trace, I can use that IP to be tracing to know whenever you connect my network. And now that IP will now tell me the website you are visiting. The next thing you know is that police has come for you and you'll be wondering how manage. Someone is actually monitoring whatever you are browsing. So that is all about the internet. So on the internet, there are several things you can do online, which we already know. You can access websites, you can visit emails, you can do quite a lot of things on the internet. We will not go much into that. Okay, by mode of explanation, we will just tell you what we call domain name server. Let me explain this. domain name server. Domain name server simply means that all those websites, like I told you, all the websites you are trying to visit, they actually have their own IP address. Now it's getting interesting. Your phone has an IP address. You are trying to visit www.google.com. What you know is that you are typing Google. What you don't know is that Google has an IP allocated to that name. So if my phone is 192.168.10.1, Google IP is maybe 8.8.8.8. What that router knows is that 192.168.10.1 is trying to access 8.8.8.8. Now it is passing through several layers. Let me demonstrate something, please. Okay, so let's say Google has an IP called 8.8.8.8, and my phone has 192.168.10.50. Now, my phone is using a network called MTN, and MTN IP is 54.494.1.1. This is MTN IP at Shoba Mast. Shoba Mast is communicating with Transamadi Mast. So MTN Transamadi is maybe using 9.9.9.9. Transamadi goes to MTN Lagos, which is using 19.19.19.19. MTN Lagos goes to MTN South Africa using maybe 11.11.11.11. What is this telling us? The only thing I know is that I want to visit google.com. But what is happening within that my device? That my device, I've sent the information that my device is telling me. I'm telling that my device that 192 is trying to access 8.8. Trying to access maybe assignment. I just type assignment. Once I type it, that information goes from here to here. This one sends it to here. This one sends it here. This one sends it here. And South Africa now sends it to, it doesn't even go to Google. Remember, Google computer may be using another set of internet service providers. Maybe they have maybe AT&T, Verizon and whatever. So all its own set of internet service providers have their own IP. So ultimately that request travels that way till it comes to Google. And Google now asks you, you are looking for assignment as a definition. Google now sends you the reply using that same path. The reply goes that way till it bounces on your phone screen telling you your search has been found. So any disruption, maybe this system, the IT guy there, like I just saw that this cable is a naked cable. And as I was passing, I mistakenly clicked this cable and this system shuts down. What will be displayed on your screen is this page cannot be displayed. Do we see that sometimes? So this page cannot be displayed. Sometimes it is not from you. You'll be surprised. You go to another website. I can visit another website. You go to Google. This page cannot be displayed. It means that maybe someone somewhere has kicked one cable. Or maybe one system has shut down somewhere. That is why you cannot visit that page. But all things being equal, the circuit has to turn around at that point and finally comes back to that point. So as we proceed with our practicals, we are going to see how this information is translated. So domain name server is simply the address that does all this resolution we are talking about. This is what I was explaining to you. A system here has typed www.something, and that www.something is being populating to different other computers. And as it's populating, it comes with a result. We're supposed to have a class activity now, but let's move straight to question and answer. Questions, please. Questions. How many people have questions? Let's indicate so we pick them. If you have, just come out so that you use the mic. If you have questions, please come to the front. Questions, please. Questions. Let's make it snappy. I saw some hands. Oh, you don't like coming out? Okay, please, you take the mics to the people asking. So after him, you ask. Someone asks here. Yeah. After him, you ask. You have a question. Is it private? They will give you the mic. So ask. Come out, come on. Go on, please.
So I want to ask, what's the effect of VPN on IP address?
Okay. The next question.
The question is kind of long, but nonetheless, concerning DNS, the domain, Google gives option to use your own private DNS instead of to use your carrier DNS. But nonetheless, once you use the Google's, like for example, in the example list of DNS, they have plain browsing, the type of IP address that won't allow you to see all those nonsense online. So nonetheless, if you use that same distance, then you go to an IP site that checks your IP, it will still show MTN's distance. I want to ask why instead of showing
Google.
private DNS.
Any other question, please? Any other question? So VPN is commonly known as virtual private networks. So normally, virtual private, what was the question? If it has IP address?
What's the effect?
Okay. Virtual private networks, in the actual sense of it, it is meant to, like what we already explained, we have an office here, we have in Abuja, we have in Lagos, and we don't want anybody to see what we are doing. So we simply tell MTN, can you do a connection whereby using your service, MTN here, Abuja and Lagos, make us a closed user group. So any information I pass through does not get seen by any other person on the internet. That is what banks do. Banks make use of virtual private network. That is why if you go to a bank, though they are on internet, their staff can never visit Yahoo, Google, Facebook, nothing. They can never visit it, though they are on internet. They are using a virtual private network that simply allows them to access only their own resources. Now, on the other way around, because I know why you asked it, sometimes when you go to visit some sites, it does not open. You simply use VPN, am I right? What is that VPN doing? When you open that VPN, I have one VPN here. Probably not on this. Okay, I have one here. Okay, this is a VPN now. What does a VPN do? The popular, Okay, so this is my VPN. I'm using Cloudflare VPN. So the popular use of VPN is to hide your origin network. Let's say I'm using MTN and I want to access a website where I can download movies. And the website is saying connections from Nigeria is not allowed. So on the VPN options, VPN is virtual private network. So another thing it does is that those that manufacture the VPN, they have networks from several countries which they allow you to mimic. So when you go to VPN and you select, like sometimes if I want to access some services that require me to be in the US, this one does not do it. Kapasky and some other ones does it. On the VPN, I'll simply select the option of USA. And once I access USA, I can access all the websites there. Because though I'm using MTN, once it gets to the internet, the IP address will change to give me the one of USA IP address. So sometimes you pay for it because you are paying to use those IP address. But nevertheless, MTN knows that you are using VPN, but they have nothing to do about it. They can't do anything about it. Because once your system wants to translate to MTN, it must pass through somewhere. So they know they are using VPN, whereby by their terms of reference, they can't restrict you because their network is meant to be open. It is only the police. Nobody can go to MTN and tell MTN, tell me what you are browsing. This can never happen. It's only the police that can go with a signed order to MTN telling them, I want to see the history of all what we are browsing. And it's at that point they are liable to now provide history of what you are browsing and also showing at what point you switched over to a VPN connection. But now it is the job of the software developers in the VPN service to ensure that your data is encrypted so that you may not be able to be traced. Because a VPN is tracing to another owner in another country. So MTN will only say that this IP address switched VPN. And for those bad guys, they'll be using different VPNs. Once they put it off and on, another IP address comes, so it's difficult to trace exactly where they are coming from. So VPN simply translates your network to a private browsing. The other question that was asked, what was the question? DNS server, yes. Now, on a router, DNS server most times just enable you to have access to the internet. And that service is supplied by just few organizations, Google inclusive. Some organizations supply it as a means of security. There are some DNS servers, we would look at it much later, but I assume he has read quite far. There are some DNS server that once I put it on my device, it will not allow people to visit maybe porn sites and some other sites. So once I put that DNS server on my router, it means anybody on that network cannot have access to those particular websites. Any other question, please? Let's quickly proceed. Okay. VPN are supposed to be, no, they are not illegal. Some people use it for illegal activities. Okay. You know, DNS is legal. So by virtue of people using it for illegal activities, you cannot tell, so it cannot be restricted. Because anybody can create a VPN. There are some phones, like my phone, I can create a VPN on my phone, such that there are some services I can give access to some of you that are using the same phone elsewhere. You can access my phone, some service, I can create it. So VPN on its own is meant to create a private network, but some people now use it to do some other things. It does not mean that they have to shut it down. For instance, there is nothing like shutting, not one person can shut down the internet. Because on what you have now learned, internet is not owned by one individual, never. So not one person can lay claim of the internet. It is only service providers can disable you access to the internet, because we are all relying on service providers to have access to the internet. So let's proceed. We are now looking at cables and connectors. Different type of cables and different type of connectors. And for the purpose of the class, you can read every other one. For the purpose of the class, we are going into cabling. Twisted pair cabling has to do with cables used for intercom and some other things. But for our own class, we are looking at Number 6E. We are looking at 6E category of cable. I don't want to give too much theory of this. So when we are talking about cable, two things we'll be looking at: internet cable and fiber optics cable. Please, you can pass. Let me create 4. We are simply looking at internet cable and fiber optics cable. So this one is what we call internet cable. You just pass it around. So that's what we'll be constructing today. We don't need laptops. So this is an internet cable. Sorry? Internet cable. Have I given? Okay. So that is internet cable. So this is a sample of a fiber optics cable. So for the purpose of this class, internet cable travels for only 100 meters before attenuation. Attenuation means loss of signal. Please, if you are asked what is attenuation, attenuation means loss of signal. Internet cable travels for only 100 meters before attenuation. Fiber optics cable travels thousands and thousands of kilometers, 100 kilometers, 40 kilometers. They travel that way. And internet cable, we usually use what we call RJ45 connectors to construct internet cables. We use RJ45 connectors to construct internet cables. So you pass it round. We use RJ45 connectors to construct internet cables. So we use RJ45 connectors to construct internet cables. And we have 8 wires in the internet cable. We also have fiber optics cable which have given us to pass round. And the fiber cables, we have the connectors. There's another internal connector for fiber cable. I think, okay. For fiber cables, we have the connectors. Please, you pass it around quickly. So I may not go much into all of this. You have to read some of this up. We want to strictly, there are different types of internet cables, but for our class, we'll be creating straight through cables. We'll come to that in the practical. We'll be creating straight through cables. Straight through cables. I've explained all of this already. Okay. Come on. This slide is very important, please, when you get the presentation. It's with your course rep already. Okay, so let's go straight to our practical. We'll be doing it on a group basis. We'll do it on a group basis. So can we nominate group leaders in each group? Group leaders in each group, please. Group leaders in each group. Two people each. Yeah, the ones that now teach the other groups. 2 people each, quickly. Please, we are very gender sensitive. One male, one. If your group has a female, the female must be there. If your group has a female, if not, you have to import females to your group. Yes, you come out, just come out. So let's look at the screen, please. Let's look at the screen. Let's look at the screen. So for today, we'll be learning one house. Let's look at the screen, please. For today, we'll be learning how to crimp land. Please, let's be together. We are learning how to construct LAN cables and test the cables. So let's look at the screen. We are going to create these cables that can be used to connect computers. And for our class, we'll be looking at what we call twisted or Cat6 cable. So we'll be looking at constructing Cat6 cable, which we have seen on the screen there. We are not doing fiber cable. Materials needed for LAN cabling. Materials needed for LAN cabling. I have showed us the cable already. Please, you collect the cables from your group. Those people that came out, collect the cables from your group. The cables moving around, you collect it from your group. Please, quickly, we don't have time. Let's be quiet. Let's do this quietly. So each group, you pass this round quickly. So that device you are seeing is called. You pass it around quickly. You pass it around quickly. Okay. Pass it quick. Please, are we together? Let's look at the screen, please. The device we are all seeing on this, the screen is showing us equipment we need for our work. The first thing is cable. The second thing is a wire stripper. We don't have that, so we'll use our fingers and what we have to strip the cable. The third one is called RJ45 connector. I've shown us that already. The next one is called a crimping tool. Let's look at the screen. The next one is called a crimping tool. And the last one is called a cable tester. We use a cable tester to test if the cables have been done correctly. If the cables have been done correctly. I'm coming. Okay. So those group people, let's have one from each group. We need 4 people now, one from each group. 4 people, one from each group should come. Let's do the first one. One person from each of those 2. Group what? Group. Where's group 1? 3, 4. So collect your crimping tool. I'll give you. Collect your crimping tool. Crimping tool, please. Let's make it snappy. We just have 1 hour now. Please bring that carton of cable. Ah, hold on now. Please hold on. Let's do it together. Let's do it together. Where's your own? Please bring cable from the ground. Help me with one of these there. Help me with one of these from that black bag. Okay. Hold on now, hold on. Hold on. So this thing, you open it so that your device can be free. Open this so your device can be free. Okay. It has a knob at the back. Okay. So the first step now is to get the cable. Send me a cable. Do you have your own cable? Get one from the floor. So the first step is to get the length you need, which you have seen. Second step is to remove the outer jacket. So there's a small, you can either use your finger or, please look at what this thing has a razor. Yes. So if you press it too much, it will cut the cable. Yes. So you can just use it to scratch the cable or use your finger, any of them. Just to create something like this. Then you make sure, like mine, it has cut my cable already, but it's too sharp. So I'm using my finger to do a fresh one. Then you cut out the white. Please, have you seen this? Have you here? Or let's see what I'm doing now. Let me do one. I'll do one, then we do the second time. Well, let me do one first. Watch me do one. Watch me do one first now. Which one is 4 ports again? When you... Okay, just leave. Just watch what we are doing here. So you see this. Let's be together. You have to teach others. You see this. When I've done my own, these two things, I have to remove it. So I'll find a way to cut it out. I don't have that stripper, so I'll still try to use. Don't worry. Let me just do one. Then we'll then do it the second time. So we then untwist it. It's always good to make it as long as this. See my finger, see my hand, like at least up to here, so that it will be easy to untwist. It's good to make it quite long to an extent. If not, you won't be able to untwist it very well. Like this one is too long, and if I leave it here, it's too short. So it's giving me a long time to untwist. So when we untwist, we'll come to the most important part. This is very critical. So now I've scattered it. Who is distracting you now? Who is distracting you? Please. Now we are to arrange it based on the specification we are following. For our own class, we say we are using straight through 568B. And this is the color. You have to cram this color. We call it, I usually call it anyhow. I call it orange, white, orange. Green, white, blue. Blue, white, green. Brown, white, brown. Orange, white is that one that has that thing that looks like orange. Mixed up, yes. Orange with stripes. Orange, white, orange. So as you are doing it, you are arranging it very well. Let it be straight together. You are not looking. Just look. No, look first. Just look. Just look. You arrange it very straight. No, you have time today. Just look. Then green, white. If we don't take time to make it straight, there will be error when it's time for usage. Green, white, blue. What's the next color on the screen? The next color on the screen. Green, white, blue. After blue, what again? No? Green, white, blue. That is white, blue. You are not seeing the color on the screen. Green, white, blue. Then blue, white. That is blue, white or white, blue. White, blue, that is this. White, blue, what again? Green. Green.
Then white, brown.
You see, as I'm doing it, I'm trying to make sure it's very straight. Then white, brown.
Then brown.
They don't fold, no. They don't fold it that way. White, brown. Brown. Please, we are coming to the very important part. Let's look now. This thing must be
Straight.
when you do it, still confirm if it is in line. Orange, white, orange. Green, white, blue. Blue, white, green. Brown, white, brown. After this now, that is when this thing comes in. See the part you need now. Please look at this clip. This middle one that looks like a blade.
Okay.
That middle one that looks like a sharp blade. Then see what I want to show you. A good cable that is crimped should be like this. It should start from here. Meaning all these edges. I say don't do it now. Let's understand this concept. A good cable, all this, it should start like this. Meaning all these rough edges should be inside here and not like this.
Shouldn't be hanging.
Shouldn't be hanging like this. So you look at it to measure the distance from when your rough edges start. Since we are not using a stripper, that would have given us a clean cut. So mine is starting from here. So that means, yes. So see, look, mine is starting from here. So I'll mark it, hold my hand there,
And bend upwards.
and straighten it. Now, not bend it, I'll straighten it again. Straighten it again. Carry that blade to the center. Cut it, let it be. You're supposed to cut at one setting, you know. Like mine did not cut at one setting, it's giving me problem now.
Not everything is not straight now.
Yes. Please, can I have your own blade? Though I like moving that red thing, I like unscrewing that red stuff.
So you can sway your
For that red stuff usually cause,
errors.
yeah. Let me just use it like this first. Now, this thing, see how you keep it. You don't keep it like this to yourself. Look at it, or you don't keep it upward to yourself. it faces you this way. This way. And this is where it enters. Like this. And not like this. Where this head is like this. So you then arrange it. Now confirm that it is still arranged again. One of my blue white looking as if it's bending. Let me try. You now try. As I put in, you're looking at it. Look. Oh.
So you don't make any.
If it is entering accordingly. You see? Orange, white, orange, green, white, blue, blue, white, green. Anyone that skip, it means it's condemned. I didn't even get the perfect shape because this thing is exposed. But it seems it has reached the end. And I'm seeing that my colors are still aligned. And I put it inside and push it to still push it. Once it makes that clip sound, it means I've successfully done one end. But there's no confirmation if it is good or bad till I do the other end. So if you are sure you're okay, you can do one end on your own. To that color, yeah.
These will be panel patch. Panel patch.
Which one is that? Patch panel. Okay. It's just to make the work neat. Like all these cables are going to a patch. I will explain it later.
We're not explaining any wire, we're putting them together. This one is white, orange. Nothing orange. White orange.
See. See what I'm showing you. 1 to 8 is working. But I made a mix up. It is meant to show, connected. But it's not showing connected because it's showing cross. I mixed up one of the cables. So batch A. Which is batch B? The other 4 people, the other 4. The other 4. Yes, the other 1 from each group. You and O. There are 4 people now. Please, the other 4 people from the other group. Yeah, group. Where is group 2? Group 2, the second person. Group 2, the second person. You. Group 3. Okay, so maybe people can shift to one side with one crimping tool or so. You can just shift to one side as you are doing it. So the other set. Please, that first set, just shift. Okay. Remaining one person. Remaining one group. Group 1, 2, 3. Group 4, the second person in group 4. Okay, you have length with the other one. And you can go. So this is what we are trying to achieve. This is called a cable tester. Okay. So we put it here. I'll put the other end here. So our goal is to make sure when we put it and press, it will show that everything is okay. 1, 1, 2, 2, 3, 3, 4, 4, 5, 6, 7, and 8. So these two, we're supposed to have, let me go to the beginning. We're supposed to have what we call a cable stripper, but we don't have it. So we use this to cut the cable instead. We can cut the length. For now, I want to use this length. Yes, it has a sharp edge somewhere, so I'll cut it. So if you look at it, it has a very sharp edge. Then it has the circle. So it is that circle one.
You used to cut?
No. I used to. Don't you not press it hard though, just to create a kind of a mark.
Okay.
When you do it, you try to make sure there was no puncture. If there's a puncture, the cable is bad, you have to do another one. So in the absence of any puncture, I'll first of all remove this wire and this thing. So I'll use that sharp edge now to remove it.